Positive inducible operons need to be activated in order for transcription to increase. The operon itself is a group of DNA coding sequences for genes and regulatory DNA sequences that control how the transcription of the operon happens. On the operon, there are structural genes that will later be transcribed and translated. The operator is a regulatory DNA sequence used by repressible operons, and since this operon is inducible, nothing will bind to it here. The promoter is the site where RNA polymerase binds to begin transcription of the genes. In this operon, there is also an activator binding site, where the activator, which is coded for by the activator gene, will bind. However, this activator is only able to bind to its site when it is attached to a small molecule called an inducer. In an inducible operon, this small molecule would be called a co-repressor and would bind to a repressor, which would then attach to the operator. In this operon, once the activator is enabled by the inducer, it attaches to its binding site on the operon and helps RNA polymerase to bind to the promoter, thereby increasing the transcription of the operon and the expression of its genes. Let's look at a similar thought process in a different way. My fish Greg loves to blow bubbles in his tank, but he only blows lots of bubbles if the water level in his tank is high. In this scenario, Greg the fish blowing bubbles is like RNA polymerase transcribing DNA. When I see Greg's water getting lower, I act as the inducer and add more water to his tank. The increased level of water serves as the activator and enables Greg to blow as many bubbles as he likes. I just can't control my feet.